Hello everyone, I am Kedar. Today we are going to talk about understanding HDRI, what is a high dynamic range imaging. The key takeaways are understanding HDRI, how to shoot HDRI, how to stitch HDRI and extract required lights. The last part is lighting the scene using the HDRI, but we are not going to talk too much about it. Because it's a general lighting where you have your lights and use the light textures instead of flat colors. Okay, what is HDR? HDR stands for high dynamic range imaging, and the image has greater dynamic range of luminosity than possible with the normal images. Also, there is a term called SDR, which is standard dynamic range, and there is another term called LDR, which is low dynamic range. So how do we get these HDRs? We shoot the same images with different exposures, and we combine them to get an HDR. So let's see the difference between HDR and low dynamic range or standard dynamic range image. Let's go to Nuke and let's see the difference between normal image, JPEG image, and EXR, which has more dynamic range. These two images look same, but when I reduce the gain, the right side image with lot of range and the left side image has less range. Left side image looks clamped, and the right side image, even when I am reducing the gain, it still holds up. Now let's see the values of the HDR. You can clearly see that the value is somewhere around 7, but whereas in the low dynamic range or standard dynamic range it is 1. Even the brighter spot like sun is still having 1 value, but whereas in the HDR this varies from 0 to 5, 6, 7. It is based on like how many images we shoot and how many images with different exposures. So here if you see, like, we have 7 images which we shot. The right bottom one is the less exposure, and the top left one is the highest exposure. Even like the first, second, third images has like similar high values, so we need to be very careful while shooting the images. HDR is all about range. So the popular image formats are EXR, HDR, and even we can store some range in TIFF, floating point TIFF, or PSD as well. Now let's see like HDR input and HDR output. This is not exactly related to our lighting stuff or like VFX stuff where we shoot different images and we combine, but the concept of HDR is same. Even while shooting, we can shoot some HDR videos. Even iPhone also has an option of HDR, but these images usually store like 1 to 2 stops of exposures. And in terms of HDR output, there are several TVs available in the market. The major types of HDR currently available are like HDR10, then Dolby Vision, HDR10 Plus, Advanced HDR by Technicolor, and hybrid log and gamma. There are different companies which are developing these standards, these technologies. Now let's move to our HDR for lighting and VFX. For lighting, we usually shoot 5 or 7 different exposures to get more range in a single HDR. There is a technique called IBL, which is image based lighting, where we take an image to light up the scene file. Using HDR texture in our lights gives more variation in the render than plain flat colored lights. Usually, as I showed you in HDR, we have range, and with that we get variation in our lighting. To get more control in lighting, we extract these textures from an HDR, and we can use these as a key texture and rim texture and dome texture, etc. So all these can be used in a separate passes so that we get a lot of control. Okay, so let's move on to shooting an HDRI. So what are the equipment we need to shoot an HDR? A full frame camera. We can shoot in crop censored camera as well, but the difference is the field of view. So if we are using a crop censored camera, then we need more images to stitch and create 360-degree pano, like you can see in the bottom image. And we need 8 mm fisheye lens. As I said, like we can shoot in other lenses as well, but we need more images to stitch 360-degree image. So for this video I am using 6D Mark II and 8 mm fisheye lens. We need tripod. Tripod is very essential to get shake-free images, otherwise it will be very difficult. Then we need a pano rig. You can see the right bottom image, which rotates 360 degrees. So if we are using 8 mm camera, then we can use like 3 angles of 120 degrees. We also need Macbeth chart for color calibration. Usually, like the input what we get is from film cameras, I mean like Alexa, Red, or those types of cameras. And we are shooting in the HDRs. What we shoot is usually like normal DSLR cameras, so the colors are different in both of the images. So that's why we need Macbeth chart to calibrate the images, calibrate the HDR and match with the plate, then use those HDRs as a light textures so that the rendered output matches maximum with the plate. So can we shoot HDR without these gears? Yes, we can. If we talk about HDR, as I said, like it has range in it, so we can shoot 5 or 7 images and we can combine to get an HDR, even with the crop censored, even with any lens, but it depends like how we need and what is the requirement. If we just need a light texture, then we can shoot light texture in different exposures and we can combine it and use as a HDR texture in our scene file. Also, based on the shot requirement, we can use blurry HDRs, like if the CG object is far from the camera and it doesn't have reflective component, then we don't notice much. Another point to notice or understand is chromatic aberration. So it is a failure of lens to focus all colors to the same point. Usually we see this issue in the edges of the image. Also, as I said, like it is based on requirement, how accurate image we need. So another point is AB, which is auto exposure bracketing. With this option, we can automatically adjust the exposure, and it shoots 5 to 7 continuous images. Here you can see the options like 5 shots, 7 shots, and in the right side image you can see the exposure differences. Like it has like 5 images, it is shooting 5 images with different exposure differences. And another point is nodal point, no parallax point, or the point at which the rays entering the lens converge. Now let's shoot something. So here I have Canon 6D full frame camera and 8 mm lens. Let's see the coverage of 8 mm lens. So this is the field of view with 8 mm lens and a full frame camera. This is panoramic, where we have the degrees for rotation. So if we are using 8 mm on full frame, which has like maximum coverage, then we can grab 3 angles, 0, 120 and 240. This one is Macbeth chart. This is for color calibration as well as gray level matching. As we spoke, here you can see different number of images which we can click. 5 images with different exposures, 2 images with different exposures, or 7 images with different exposures. If we go to AEB settings, there you can see different number of images with different values here. This way we can adjust number of images as well as exposure difference. So here you can see like these are 3 plus 3 plus 1, 7 images, and we can adjust the difference between the exposures as well. Let's click images. This is vertical setting, so 180 degrees vertically and 360 degrees 120 into 3 horizontally, so 3 angles. There are few other things which we need to understand. One is reference spheres. Reference spheres are to understand the lighting of the location. Usually we shoot these spheres and Macbeth chart with the input, and it helps to understand the light position and intensity or exposure. Macbeth chart is used for neutralizing the image or as I said, like matching HDRI colors with the plate. We create ref spheres in CG as well in the scene files, and we try to match maximum possible with the ref spheres from the plate with the CG. One is chrome ball. It is the right side one, which is used to understand the light position, direction and the rotation, and the second one is gray ball, where you understand the intensity and the light colors as well. Here I am showing these spheres as reference spheres. These are for references, like the position and everything we can see and we can match with this. But earlier there was a method to shoot the HDRI with chrome balls instead of using 8 mm lens or some other lenses. Apart from this, there are few other points which we need to keep in mind while shooting HDRI. HDRI is not only for perfect reflection in the scene but for lighting as well. Choose the proper exposure for capturing, and then use the auto bracketing which is like +3 stops and +3 images and -3 images. Keep focus and white balance same for all the images. Maximum try to use RAW format images instead of JPEGs. it is very important to understand the CG element, like where we need to place the CG element and what is the lighting conditions there and which lights are affecting on that. Based on these things, we can judge properly and we can click the HDRIs properly. Also try to use the camera vertically, because it gives you like 180 degree from top to bottom, where like in horizontally like three angles are good enough, like 120 degrees each to cover 360 degrees total. Also it is very important to understand the shot requirement. So once the shooting part is done, now it's the stitching of HDRI. Like as I said earlier, like if we are using 8 mm lens, if we are using like 3 auto bracketing images, then 3 into 3, which is 9 images per HDRI. Similarly, same like 5 auto bracketings, then 15 images, and 7, then 21 images. If we are using crop sensor camera, then the number of images may change. There are several softwares available in the market to stitch the images, like Autopano, Giga, PTGUI, and even we can create HDRs in Photoshop as well. We can use any software which is comfortable for us. Here I am using PTGUI. Let's move into PTGUI. So here I have like 2 sets of images. The first one like has 25 images, 5 into 5, so 5 angles with 5 exposures per image. So here if you see the details, it has 8 mm lens with 70D, which is crop sensor camera. So here it is showing approximately 12 mm. So as I said, like 25 images total, and this is the lowest exposure, and this one is the maximum exposure what I shot. So once we combine, this will give us like from lowest to highest in that range. So this one is circular crop for stitching pano. Now let's try to create pano HDR with all these 25 images. So there is a button called detect here. So once we click that, it takes some time and it gives us the image. So now you can see this has approximately 13,000 by 6,000, and here you can see like 25 images and 360 degrees into 160. So 160 means vertically 160. So here in the bottom you can see some area is missing, so we need to paint this in order to create proper HDR. So there are few settings here. So this one is HDR, and you can give high dynamic range in this one. So first one is with crop sensor camera with 5 exposures, and here the second set of images has like 7 exposures per image, and as I said this is with full frame sensor and 8 mm camera, so it has 7 into 3 images. So this one is the lowest exposure, and let's see the different exposures in this one. So this is second level, third, fourth, and we have total 7 number of images here. So this is there is another level, I guess. Yeah, it's a bit slow. Yeah, this is the last one. So this is the maximum exposure what we shot here. So as we saw in the first set of images, here also let's see how the information is. So 8 mm here again, 6D Mark II, and which shows 8 mm full here, fisheye lens. Let's create HDR with this as well. It takes a bit of time. So yeah, now it is done. So this is the second HDRI, which is exterior, and the size, if you see here, it is approximately 10,000 and 360 into 180 degrees, and here you can see 21 images. So this is the metadata, and here this is the render settings. You can see like we have HDR option enabled, and EXR, and you can just click render and you get the HDR EXR image output. It takes some time to render. Let's move further. So after the stitching part is done, before extracting lights we need to work on the below points. So we need to neutralize HDR first, and then we add color correction which is matching with the plate. So I prefer adding those color correction values inside the 3D scene, either Katana or Maya or whichever it is, instead of applying here in the HDR, because if we have single sequence with single HDR and a few shots are a bit different in terms of color or in terms of temperature, then it is very difficult to create so many HDRs per shot basis. Instead, create one neutral HDR for a sequence and use the slight color changes in the scene file. Along with that, we need to paint out unnecessary elements in the HDR. While painting, we need to keep in mind that HDR is all about range in the image, so we need to make sure there is a proper range in the painted areas as well. So once the painting part is done, now we can extract the lights from HDR. One thing to keep in mind is in CG, the dome light is infinite, and the light placements are very important in the scene file. So we need to cut the images like key light or rim light, and we need to use those textures with the proper placed lights inside the scene file. Once we extract the lights, then we need to paint out that information in the dome, because if we don't paint out, then it will double up the lights. We can also adjust the intensity and or exposure or slight color variation inside the 3D scene file. Now let's move into the other software to see how we can cut the lights. So this is Nuke, and this is the old image which we already saw. Okay, so this one is the HDR which we baked. So this part, the bottom part, as we discussed, we need to fill up with the same texture. And here this is the key light. We need to extract this. There is another small one, but this is not affecting too much. So if you see here, as we discussed, this has values more than 1, somewhere around 2. This is also based on how we shot the images, like the minimum exposure and the maximum exposure. So let's use crop here, and we are cropping the key light here. Now in this image we have range, so this image can be used as a light texture inside the 3D scene file. So once we have extracted the key light, then we need to paint that area, otherwise it will double up the intensity there. So we have roto paint node, and we can just paint the area or the pixel which is near to that light. It is not always necessary to be very accurate in terms of painting, but we need to keep in mind that the values what we are painting are approximately similar to the adjacent areas, because we already extracted the key, so it needs to be flat in this area, so that once we place the key light properly in our scene file, it will give us the proper results. So that's why we need to understand the requirement. So even in this area also we have some additional values. So this is another light, we can paint it here the same way. So it's the same adjacent area we are painting here. So this light is a bit too far, but if you see, like, the light is affecting only near to this area, but if we want our CG element in some other place, then we can live without extracting that light as well. So now, because the areas are painted, now we need to paint the bottom part. Here we need to create an additional area, because while shooting we didn't get this area. So the same way how we painted that, we can get the similar area, the adjacent area, and we can create it. And this is not the only way to paint these areas. There is another method. We can convert this lat long image to mirror ball, and we can paint there and convert it back, and we can use that. Now if you see here, this is a bit easier to paint. So it's the same thing, but the methods are different. So here we have a paint node, so I have painted here roughly, and then I have converted again back to normal here. So yeah, now if you see, is the same from mirror ball to lat long image, and this is what we are getting with that. So similarly, like, this is one half, the bottom part, and I have converted the same thing with the top part. So now you can see, like, this is the top part, and the same way we can paint if required, and convert it back. So these can be rendered out again as north dome and south dome. The top one is called north dome and the bottom one is south dome. So let's use the right node here. So it is basically for getting the control, and if required we can tweak these images separately as well in our 3D scene. So here the same way, south dome and north dome, and similarly we can use this key as well, and we can save this key light separately. So let's do a right node and save as key.exr. So now we have south dome, north dome, and a key light. So similarly we can extract different lights in a HDRI. And once the extraction is done, we can light the scene with these HDR images. As I said earlier, now these images can be used as a textures in the lights to get variation. And as I showed you earlier, that the size of the HDR depends on like how we are shooting it and how many images we are shooting. So depending on the shot requirement, we can use either 2K, 4K, 8K or 16K HDR images for dome, and we can extract the lights from that and how accurate we want. Based on that, we need to go high res on the HDR. And as discussed earlier, based on the requirement, if we need more control in comp, we can separate these light passes as well, like south dome separate, north dome separate, key separate, rim separate, and we can give the we can adjust the values in comp as well. I'm not going to show this lighting the scene part because it's fairly simple and easy. And this is what I have for this video. I have tried to keep this video as simple as possible and maintain the relevant information. Hope you liked it and it is useful. Thanks for watching, and please subscribe my channel Myka VFX. Thanks again.